Second question, let V be a vector space, V be a vector space over a field F and S1 S2 contains in V. If S1 contains in S2, then we have to show that S2 not contains in S1 not. Now solution, we have what we have V is a vector space over a field F and S1 S2 contains in V such that S1 contains in S2. Now let phi belongs to S2 naught. Therefore phi of alpha equals to 0 for all alpha belongs to S2. That implies phi of alpha equals to 0 for all alpha belongs to S1 because S1 contains in S2. So alpha belongs to S2 के लिए phi of alpha equals to 0 होगा. That implies phi belongs to S1 not. Therefore S2 not contains in S1 not. Now third question, let V be a vector space over a field F and UW be two subspaces of V. Now we have to show that U plus W naught is equals to U naught intersection W naught. Now solution, we have V is a vector space over a field F and U comma W are two subspaces of V. Therefore U contains in U plus W, also W contains in U plus W. This implies U plus W naught contains in U naught and U plus W naught contains in W naught, because we know that if S1 contains in S2, then S2 not contains in S1 not. अभी previous question में हमने प्रूव किया है. So that imply U plus W naught contains in U naught intersection W naught. Now let phi belongs to U naught intersection W naught. Therefore phi belongs to U naught and phi belongs to W naught. That implies phi of U equals to 0 for all small u belongs to capital U and phi of small w equals to 0 for all small w belongs to W. Now let alpha belongs to U plus W. Therefore alpha equals to small u plus small w for U belongs to U and W belongs to W. Therefore phi of alpha equals to phi of U plus W equals to phi of U plus phi of W. Phi of W equals to 0 plus 0 equals to 0 for all alpha belongs to U plus W. Therefore phi belongs to U plus W whole not. Therefore U naught intersection W naught contains in U plus W whole not. Hence U plus W whole knot equals to u naught intersection w naught.